I'm filming this on the 3rd of July. I thought we'd be a little patriotic in honor of 4th of July. I thought I would sing the national anthem. No, not really. Okay. Hey, if you're here for lesson... Oh, it's binaries. 74. No, not 64, 8, and 2. Okay, so do the math there. We're going to solve some absolute value equations. Another confession, absolute value equations are not my favorite thing to do. There's a little bit of a trick you got to watch out for. I try to show you why that trick is true here behind me as we get started, and then we'll move into how do I do the problems and finish this so I don't have to ever do this stuff again until next year. So let's get out that pencil. You need your handy dandy notebook. Excuse me. You're gonna need straight edge, I guess, maybe, possibly. Might happen. I don't know. Homework papers? Yeah. Alright. Let's get a move on it. Absolute value comes with these little fancy bracket things. Something's inside of it. And these are not just expressions, these are equations. And, as you know, absolute value just means how far away am I from the origin, from 0 on the number line. Actually, we can do this in 2 dimensions, and we can find out like the distance between 2 points. That's the absolute value. In vectors, it's called the modulus. All right, whatever. I have an expression here: x plus 2 equals 6, and I just want to kind of think this out here. What x could be in order for the answer, the absolute value of that stuff inside these brackets, would equal 6. Okay, so I've drawn the number line, gone from -6 to 6. And in both of these we have whatever our x value is, we have to add 2 to it first. And on the number line, adding 2 always makes us hop over to the right. Okay? If it was -2, we'd have to hop over to the left. So we want to think of anything going this way as a plus, and anything going this way is going to be a minus inside the brackets. So that tells us that no matter what, I kind of think of this as like and 2 or 2 and x. A 2, a plus 2, and x. So if I'm over on this side, it's pretty easy. If I go 2, and then I go x units out to 6, well, it's pretty obvious how far x must be. The value for x must be 4. I go 1, 2, 3, 4 hops over to get to 6. Now, it's not so obvious on the other side, okay? Because first, I take that plus 2 hop, and now I'm thinking, well, how would I get to 6 away from the origin? I've already gone 6 away from the origin on the positive side. What about on the negative side? Okay, so you can take a big jump this way. And remember, any jumps you take back this way would be negative jumps. You have to take 1, 2, 3, 4, 5, 6, 7, 8 negative jumps on this side to get to -6. We know that it could be -6. Whatever happens in here, the sign gets ripped off of it, and we just have a number. We don't have a plus number. We don't have a minus number. We just have a number. It's an absolute value. So, said that should be -8. -8 and 2 is -6. The absolute value of -6 is 6. Thumbs up, check mark. On this side, that was easy. We can have a 4. 4 and 2 make 6. The absolute value of a positive 6 is 6 as well. Okay, but I want to give you a little bit of visualization of that number line thing and absolute value so you can kind of maybe grasp conceptually what we are going to be doing as we tackle absolute values. So some absolute value problems are just ridiculously easy, like this one. What's the absolute value of x for it to equal 5? What's the value of x if its absolute value is 5? Okay, well, golly, what could x be? Well, same thing here. We're looking at how far away we are from the origin, from 0. We can go 5 this way, we could go 5 that way, and both of those answers would be 5 away from the origin. The absolute value here would be 5. The absolute value here would also be 5. So x could be plus or minus 5. We're going to write it like that with a plus e and a minus e there on the same answer. So some of them are fairly straightforward, and you just got to put your thinking cap on here and remember the number line in order to get an answer. How many units am I away from the origin? Example 1a is like that one I just did. Example b is x plus 3, and we have here that it equals 16. So we can use our number line again and go all the way out to, let's say we're going out to 16. We're just kind of imagine that we're going out to 16. And we could imagine that both things are going to take a plus 3 type of hop. And then we're going to say, like, what could x be in order to get to 16 away from the origin? So you could say, well, I'd have to take a jump of another 13 in the positive direction. Or from here, I'd have to take another jump out this way backwards, 19 total places. Okay, there you go. And so we could have our answers, which they like to put in brackets of being a negative 19 could be the value for x. 19 hops back this way, and 3 hops that way would get me to the origin. Or 3 hops and another 13 hops could get me back to the origin. I kind of like this visual way of doing things. That's not what they do in the book. Shame on them. But I've been watching a great courses thing on visualizing math, so I feel like I gotta use what I'm learning here. What the book would do would be to take this thing here and say, this absolute value, that the thing inside the brackets before we rip the plus or minus off of it, could be a positive or it could be a negative. We have to account for both possibilities. So the answer could have been a positive or a negative 16. And then we kind of just do this. We turn these into parentheses, and we go ahead and we do the math. We'd say, well, let's take 3 away from each. So we could have negative 3 plus 16 or negative 3 minus 16. You see what I just did? X could equal either this right here, which is a positive 13, or it could be this right here, which is a negative 19. It's the same thing I just did on the number line. But the only trick was I took out the parentheses and I counted for the fact that the value of whatever was in those brackets could have been a positive or a negative value, because when we take the absolute value of something, it tears off those signs and we're left with what we're looking for. We're looking for a 16. But it could have been that this equals negative 16 and the absolute value of negative 16 is 16. Okay, so we have to watch out for that. That's really the only little trick. And I've given you a visual way of doing it, and I've given you an alternate way of doing it that's even different than the way that the book has it. You can use the book way. It's just dumb. All the other types of examples are just using our basic algebra skills in order to isolate that absolute value thing all by itself. So instead of it being like x plus 3 in absolute values, if we had something like 3 times the absolute value of x equals 18, because that 3 is outside of the operation here, this is kind of like when we do PEMDAS, we do parentheses, but absolute value would go first too. We can divide by 3 and not really mess with the whole situation here. And so we could have the absolute value of x equals 6. Well, remember, we could put a negative 6 in there, and this would be true because we're just saying how far away from the origin. We want to be 6 away from the origin. So the answer to this could be negative 6 or 6. But this was just a case of isolation. This was a case of moving everything else that's not inside the square root, or sorry, the absolute value thing over to the other side and then solving. So that's a situation that you might come into Or make it one bit harder than that. Let's make it, ooh, they use that. I'll use something that's like it. Let's do 20. Okay, can't mess with this yet, but we can get that, move it to the other side by dividing both sides by 4. So the absolute value of x plus 3 is 5. Okay? And now we're going to play that game. We can picture this on the number line, and I'll do it again on the number line, just so you kind of get that method down. That, no matter what, we're going to have a plus 3 in there. 1, 2, 3. And then we're figuring out what x values must be in order to make us 5 away from the origin. Okay, so 5 away from the origin is either 5 or negative 5. So from here, we could go another 2 hops in the positive direction, or we could go another, how many is this? 1, 2, 3, 5. We have to go 8 hops in the negative direction. And so there would be our answers. Our answers would be negative 8 and a positive 2. Or we could play the little game that they did. We could put plus minus 5 here. Account for the fact that it's going to be 5 to the left or 5 to the right, and then remove the absolute value and put parentheses in instead, and finish this off by going minus 3, minus 3. So it's either positive 5 minus 3, or it's negative 5 minus 3, and lo and behold, we get a positive 2, and we get a negative 8. Same things that we had above. See that? See what I did? You can do it too. You can do it if you want to do it. Like painting, kind of. Example 3 is the last thing, and it just has a couple of special cases. And the special cases are when it doesn't work. Okay, so absolute value is one of those things where we can write an equation. We can write basically any equation with absolute value, but that doesn't necessarily mean that it's going to work. That is going to equal what's on the other side. Okay? So, or we can have that there's only one answer to it. Okay, so we could have 2 answers, 1 answer, or no answers. That's, I guess, what I'm getting at here. So if I do the math here, this is not inside the brackets, so I can move it to the other side. And then we get x minus 6. The absolute value of x minus 6 equals 0. And this is not so bad, because now we're on the number line. We're like, what thing, if I go 6 backwards, is going to get me back to 0? Right? I got that minus 6 hops. I need to know a value for x that's going to take me back to 0. Must be positive 6. I have to start from here, okay? And I have to go to 0. So there's only one answer for this one. I have to go 6. I don't have anything over here. I only could jump 6 back to the origin. Okay, so that's a case where there's only one answer and only. That's a special case. And another special case is this right here. And I'm going to go ahead and make that number line. I'm going to put an 8 out here, and I take a plus 4 jump. Okay. The problem is, once I've taken that plus 4 jump, there's no way for me to find a value for x that's going to work here to generate a negative answer. Okay, absolute value tells us just how far away are we from the origin without any signs. So if I say, what's the absolute value? And I say, well, negative 8, you'd be like, duh, I can do it on my calculator. My calculator tells me it's 8. You don't get an answer there. So this one, we have no way to answer that problem. I kind of like those. It's like, null set. You can't make me answer that question. I mean, you kind of did, but you kind of didn't. I can write a slash thing through it, and it's still right. So take that, math teacher person. Everything else is like one of these. Match up the work in your text with one in the examples or one that I did. Should do fine. God bless America.